Welcome back. Now that we've gone through our 6-step process, it's time that we try our first normal problem. So here is our first normal problem that we're going to do. And we are going to start this problem by interpreting and defining. This means I'm going to read through the problem to figure out what's happening, and then I'm going to define my random variable x. I like to underline, circle, highlight all of the various things I read that might be important. So each American uses an average of 650 pounds of paper in a year. Suppose that the distribution is approximately normal, with a population standard deviation of 153.5 pounds. Assume the variable is normally distributed. Find the probability that a randomly selected American uses more than 800 pounds of paper in a year, less than 400 pounds a year, between 500 and 700 pounds a year. Okay, so now that I'm reading this, I pulled out some key things that I think might help me in later steps of my process. But I'm going to start here with my random variable x. I need to define it using what I've read here. So I'm understanding that we're looking at paper usage, and it seems to be annual paper usage. So maybe I will say annual paper usage for an American. And I need units, and my units here are pounds. So I made sure I have defined my variable. So I've interpreted my problem. I'm looking at how much paper Americans use annually. I've defined my variable, so I'm done with step 1. Now I need to check. I'm checking, can I use a normal model? In this problem, they tell me the distribution is approximately normal and the variable is normally distributed. So this is a normal model. Approximately normal is acceptable, so I have checked. It's not always going to be this straightforward and easy to do this step 2 check, but we want to get in the habit of writing it down and making sure we do it. So now I need to identify my parameters. This is the mean and the standard deviation from my problem. As I was reading, I saw the word average, and I underlined that. So that is 650 pounds. And I found my standard deviation, and that is 153.5 pounds. Now, I don't require you to write the units down here in the problem, as long as you have appropriately defined them up with your random variable. So 650 pounds and 153.5 pounds. Done with my parameters. Now I am on to drawing, calculating, and translating. This draw, calculate, translate is going to happen for parts A, B, and C. So let's start with part A, more than 800 pounds. So I'm going to draw my normal model, and I'm going to label it. So there is my appropriately drawn model, and I'm going to take this and I'm going to draw it as a picture. So more than 800 pounds looks like that. Now I can write this in probability notation as the probability of, and then inside parentheses, I'm going to write an inequality that relates to that area. So that is that x is greater than 800. Probability that a randomly selected US person uses more than 800 pounds of paper. Okay, now I have a couple options. I am going from an x value to an area. I can get there via a z-score. So I can go through and calculate a z-score and then use my table or calculator, or I can go straight from an x value to an area. I'm going to show you how I would do this if I was going to find a z-score first. So if I was finding a z-score, I would also label a second axis. Directly below, we can have 2 axes for this distribution. And so my z value is x minus mu divided by sigma, or 800 minus 650 divided by 153.5. 800 minus 650 divided by 153.5 gives me 0.977. Now, I could then use that with my table or my calculator. Doesn't really matter. I am not going to. I'm just going to use X's. But it is a good idea to be able to do this and to be comfortable and fluid calculating that z-score. Okay, so I want to know how to find this. I'm going from an X value to an area. That means I'm going to use normal CDF. So I am going to write normal CDF of my left limit is 800. My right limit is infinity, but remember, our calculator can't do infinity. The mean is 650, and our standard deviation is 153.5. 800, 1E99, 650, 153.5. And that gives me probability of 0.164. Okay, so now I have done my calculations. Next, I need to translate. So what does this mean? What does this mean for somebody who doesn't care about statistics? This means the probability that an American uses more than 800 pounds of paper is about 16.4%. So I've taken this answer and I've put it into context with units that people can understand. So that was part A. Part B, I need to go back through draw, calculate, translate. So draw. It's a separate part of the problem. It needs its own drawing. You must draw a different drawing for each part. If you don't, you're going to end up very confused. All right, so this area here is the probability that X is less than 400. And that I will do normal CDF of negative 1E99, 400, 650, 153.5. It's a good idea to write out what you're going to put into your calculator so that you can see easily if you've made a mistake there. So negative 1E99, 400, 650, 153.5, and I get 0.052. So the probability that an American uses less than 400 pounds of paper is about 5.2%. All right, now for this last part, I haven't left myself much room, but I think we can do it. We're getting faster and needing less space each time we do it. The more of these you practice, the better you are going to get at them. Drawing your normal distribution should be really quick, and you will get good at it. So we're looking at the probability of between 500 and 700. You don't need to draw this to scale, but you need to make sure that numbers that should be to the left of each other are, so that your numbers go in sequence. So I am looking for that area, and that area is the probability that 500 is less than X is less than 700. So again, I'm going from X values to an area. So that is my left X, which is 500, my right X, which is 700, my mean, which is 650, my standard deviation, which is 153.5. So normal CDF, 500, 700, same mean and standard deviation, and that gives me 0.463. So the probability that an American uses between 500 and 700 pounds of paper is about 46.3%. So there we go. That was how we would solve a problem using our 6-step process.